So I'd like to first thank my co-authors, Bonnie Chow and Song Zhou, and we had a wonderful research assistant, Chow. So when we want to answer the question of how do we assign students to sections, we're actually answering questions about classmates. So what's the impact of classmates of higher past achievement on a student's learning? Their family SES, their attitude toward learning. Once we understand how classmates affect them, we can think about how we would want to group them. So for instance, we want to group students with the same past achievement, streaming across schools or tracking across classrooms within the school. Likewise, do you want to have students the same SES together or separate them out and mix them? And also the attitude toward learning. So these are a set of questions I'm going to try to answer, and they have implications for how we arrange students. So first, let's look at students' past achievement. One impact of having students with higher past achievement is that if I'm a student, they know more, they can help me. I can ask them questions, they can explain things to me. So this might help me learn more. But there's also a downside, which is that if most of the students in my class are much better than I am, then I'll have fewer opportunities to help them. And helping actually is much more important than getting help. If I help someone, I have to think about how to explain it to them. I need to reorganize my understanding. So when I'm teaching someone else, I actually learn more than if someone's explained to me. So this is the downside of grouping students together. If we look at family SES, typically kids who are richer, they have more books, more rulers, more computers, more educational resources, and they can share those with me, or they can also use them. Like they talk about how they did the problems, if they travel, they can share those experiences with me. And when they do that, I can learn more. I have more opportunities to learn, and hence I typically learn more. So typically family resources help both the individual student, but also classmates' family resources will help a student. And we also have attitudes toward learning. So typically, if you're surrounded by students who have better learning attitudes, they're going to express them more. It'll tend to show in their behavior, so they model them for us. This tends to cultivate a very positive culture. And it creates a norm of how you're supposed to behave, and what attitudes you're supposed to have. That makes it much more likely that I'm going to have similar attitudes, and if I have such positive attitudes, I tend to learn more. Now, let's look at how we group people together. You can group people together by making them very similar, or you can mix them so they're very different. So, as I said earlier, if you group people of the same ability together, you're pretty much the same level, you have fewer differences. So there are fewer people who can help you, and also fewer people you can help. And so you might tend to learn less that way. But on the positive side, if you group students that are very similar together, it's easy for a teacher. So if a teacher is like facing a very narrow band of abilities, they can target their lessons for those students. Whereas if the ability levels are really broad, it's much harder to address very different students' needs. So, but this is very different at school level versus classroom level. In a school, if everyone's in a school is very similar in their ability levels, the teacher basically prepares one lesson. So like, say geography, they have one lesson, it's pretty much the same for everyone because the ability is very similar. But if you do it across classrooms in a school, so you have one class that's really high ability, one class that's really low ability, the teacher has to make multiple lessons now. So it's harder for a teacher. And so even if they could customize their instruction, they're less likely to do so when you have grouping across classrooms. But within a school, it's much easier. Also, because your students are going to be very similar in ability, they might be more similar in other ways. And in general, this is a birds of a feather impact. That people who are more similar to each other, they're more likely to be friends, they're more likely to trust each other, and more likely to help one another. It's also known as homophily. And as a result, you have less conflict, and you might learn more because of that. And so if you look at racism, this is like a basic pattern of that. People of different races are different. This is partially why there's more conflict. And so if we look at family SES, you can have the same effect. People with similar SESs might be more likely to be friends with each other, trust each other, and help each other more. But you also could have a diversity effect. This is where people are different from each other. You expose to different ideas and different experiences. That's helpful in several ways. First, it legitimizes different opinions. So if everyone's very similar, it's really hard, actually, to have a different opinion. You're much more likely to go along with the group. But if lots of people around you are different, it's kind of normal to have different ideas and different opinions. So as a result of that, if you're in a group of people like that, you tend to have more ideas that are expressed. You have a lot less premature consensus where you agree too quickly. And you also are more likely to recognize flaws in other people's ideas, correct them, and then improve them. And there's also a possibility that the differences are really useful only for the higher ability kids. So it might be that the higher ability kids can better take advantage of differences and might be cognitively more difficult for lower ability students to understand what's going on and benefit from all these differences. We can also group students by learning attitude. So learning attitude is a little difficult because you don't see it so easily. So if you have greater differences in learning attitudes, you're going to have much greater contrasts. You're more likely to see differences between them. And so if you have students with very different learning attitudes in one classroom, you can see very extremes of like really good attitudes and really bad attitudes. Those students will also have particular behaviors associated with that. Students who have good attitudes are going to probably talk more about academics, talk more about the books they're reading, and discuss them, whereas people with bad attitudes are less likely to do those sort of things. And so there are also consequences to it. So kids in a classroom typically know how well students are doing, and they can see this type of attitude, this type of behavior is very positive, they tend to get better grades. You know, a person with poor learning attitude, their behaviors are very different and the grades are different. So it's easy to see when you have higher contrast. And so one possibility is that students might recognize this, see which ones are better in terms of learning, and then follow those sort of attitudes and behaviors that are positive rather than negative, and then consequently learn more. So that was a lot. So I'm going to put it together in a theoretical model. Classmates with higher past achievement, we expect them to have more help, and so I'm studying students' reading. So students' reading achievement should be higher if your classmates have higher past achievement. If you have richer classmates, you're probably going to do better because they can share resources with you and share experiences with you. Likewise, if they have better learning attitudes, they're probably going to model it for you, set good norms and standards, and more likely follow those. So all these are positive. Now, when you group students together, it's possible that when you group students, you're customizing the instruction. The teachers are catering to particular sets of students, and that might help you learn more because the teachers are adapting the instruction for your particular academic level. But if it's across courses, you might have fewer help opportunities. If you're very similar, there are fewer people who know far less than you and fewer people know far more than you. So there are fewer opportunities for the class overall. So that might reduce students' reading scores. Hopefully, if you're more similar, you might befriend one another more, help each other more, and learn more. Family SES, you might have the homophily effect, or you might have a diversity effect. If you group students by family SES, they're going to be less diverse. You're going to have less ideas and less correction of wrong ideas. And lastly, if you have similar reading attitude, the contrasts are much smaller, and you might have lower reading scores. So that's the basic model. Any questions on this? Okay, so in order to test this, you need a lot of data. Fortunately, there are international studies where people have collected a lot. So I specifically looked at the PEARLS data, which has 208,057 fourth graders in 40 different countries. And so they took reading tests, and they also answered questionnaires along with their parents, teachers, and principals. They also answered questionnaires. These questionnaires were forward and backward translated into different languages, and they show good invariance properties across countries. I also combined that with economic data from the World Bank, so country income, the degree of inequality in each country. In addition to doing the entire data set, I'm also interested in, are these effects different for different levels of ability? So the bottom 10% of students by achievement, are the relationships very different there versus the bottom 20%, the bottom 50% versus top 50%, top 20%, top 10%. So we can see if there are any variations. So in order to analyze these complex data sets, there are a lot of difficulties we have to address with statistics strategies. So first is the precision of reading competence. So how do you measure how well their reading skills are? And we use something called an item response model that gives us more accurate measures of their reading ability. There's also sampling bias. You're sampling from populations of millions of people. And so what we do there is we use a plausible value analysis, which reduces the sampling error. We also have missing data. In some countries, like Canada, unfortunately, they lost all the parent questionnaires. Like it was in a truck going down the road, and it just disappeared. So Canada is not in this data set because of that reason. But otherwise, if you have small pockets of missing data, we can estimate what they are using Markov chain, Monte Carlo, multiple imputation. We also have nested data. So the students are within schools within countries. And if you don't model that properly, you're going to get biased results. And so we use a multi-level analysis, also known as hierarchical linear modeling. And also, we're testing many hypotheses at the same time. And if you don't take this into account, you're going to get a lot of false positives. You have like 20 hypotheses. You're just very likely going to have one of them be significant just because there's so many hypotheses. So to reduce the false positive rate, we use something called a two-stage linear step-up procedure. So all these problems are taken care of by specific strategies. We also control for other variables that I haven't mentioned here, student past achievements, country income, country inequality, along with other country variables, family variables like family SES, home education resources, family structure, language spoken at home. We also control for school variables like school violence. We control for teacher variables like teacher gender, and also other student variables like student gender, reading attitude. So it's a really long list of variables, and this is really important to control the false positives. So we get to the results now. And so the results are going to be in the format of, if we increase something by 10%, what's the impact on a student's reading score? So if a student has higher pass reading achievement, they tend to do better. They tend to get 5 points higher on the reading test. If a country makes 10% more money than other countries on average, a student's going to get 4 points more on the reading test. If there's greater inequality, it has a tremendously powerful effect. A country is 10% less equal than our country, their students, on average, score 20 points lower on reading. Streaming is even more powerful than that. So if you group students by ability into schools, so like Singapore, Hong Kong, they group their students by school. So all students are school, very similar ability. That, on average, increases the reading score by 45 points. But it's not a simple linear effect. So this is a curve of that effect. So the blue dot is the mean. That's like the average person, the average school, in the average country. The solid blue line is the values within 2 standard deviations, basically the middle 90% or so. And then the little dotted line, it's not really dotted here. This part is supposed to be dotted. That's the outside 5% on the other side. And the x is a turning point. So that's the point where it changes direction. So you see that most schools, they're better off more clustering. But at the really high extremes, they're actually much worse off. Because what happens there is that the students are so similar, they're not getting helping opportunities. So it's good up to a point, but it drops when it gets too homogeneous. So if you look at family SES, if your family is richer, 10% richer, you tend to have 4 points higher reading scores. If your family has more home educational resources, books, computers, you also have 4 points more on your reading test score. Parent reading attitude is also important. If your parents have 10% higher reading attitude than average, you tend to have 2 more points. And your classmates' family SES is also important. So if your classmates on average have 10% higher family SES, you have 4 points more in your reading test score. This also increases, but it increases at a decreasing rate. This is called diminishing marginal returns. So when you have really high SES, the impact is much smaller. And also, if your classmates have a lot of home education resources, your reading test scores are on average 5 points higher. Girls do a lot better than boys in reading. 4th graders, girls have a huge advantage. On average, they score 13 points higher than boys. If a student has a 10% better reading attitude, they tend to score 3 points higher. If they have 10% higher reading self-concept, they score 6 points higher. And if their classmates have higher pass achievement, they score 2 points higher. This also is a nonlinear effect. So you see at the extremes, you do better. When you have much higher classmates with much higher past achievement, you're better off. If you have classmates with much lower past achievement, you're also better off. This is exactly what a helping hypothesis would tell you, that when you have more help opportunities, you do better on both sides, either helping other people helping you. And also, classmates' reading attitudes, if they have 10% better reading attitudes, you score 1 point higher. Now let's look at classmate differences. Classmate differences is the opposite of grouping classmates together. So if you have very different classmates in terms of past reading skills or past achievements, you score 1 point higher. There's exactly the same effect as helping opportunities, just measured in a different way. So you see consistency across helping opportunity hypotheses. This also has a nonlinear effect. Most of it is in the extreme. So there are some classrooms where there are extremely huge differences in classmates, but by and large, it's increasing. Likewise, for reading attitudes, it does support the hypothesis of crowd-crossing cases. If your classmates are very different in terms of learning attitude, you score 2 points higher. Similar sort of pattern where most of it is increasing at the extremes. When it's really, really different, you do worse. Now let's look at achievement subsamples. Are the effects different for students with different ability levels? And so I'm just going to simplify this to, like, if it's the same, it's just going to be yes. So if you group students across schools, the impact is basically the same. There's not a significant difference regardless of how smart you are. Likewise, for classmate family, yes. It doesn't really matter how smart you are, the effect is very similar. There's a difference for differences in classmate family SES, though. The more variation you have, there is a benefit, but only for the top 50% and top 20% of students. It doesn't really matter for anyone else. So it's really the smarter kids and they can take advantage of diversity. Home education resources, the effects are the same. Past achievement, it's the same for everyone except for the top 20%, top 10%. For them, if their classmates are not as smart, or lower past achievement, they're better off, which is completely consistent with the helping hypothesis, that when they have more students they can help, they actually learn more. We see a similar effect for past achievement variance. Same story, basically. Also, for reading attitude, it only affects the bottom 50%, 20%, 10% of students. Reading attitude has no impact on students who are above the 50 percentile, probably because they already have good learning attitudes. So this is truly a modeling effect. It really helps poor students. And lastly, reading attitude variance is the same. So this gives us several implications on how to arrange students. First, we want to group students by school. That makes it easier for teachers to customize their lessons. And we want to mix students within these classrooms. So you can't have extreme homogenization where everyone's identical. You need to have some variation in your classrooms. This way you have more help opportunities. And for high-achieving students, you want them to have lower-achieving students, but not a huge variation, because you want them to have the similar situation the teacher has, a small band of students that they help. It's easier for them to adapt their explanations. If the students are too broad, there's too much variation, it's hard to explain to students of very different ability levels. So you have customized instruction and helping opportunities interacting with each other to reinforce their effects. For low-achieving students, it's really helpful to have a model of people with good learning attitudes. So you want to make sure that if you have low-achieving students, you have someone in class who has a good learning attitude, and they're more likely to pick that up. And it doesn't hurt them, because they're quite resilient in terms of learning attitude. Also, for high-achieving students, you want to mix students by family SES. There's the diversity effect. But there's also a trade-off, because in many countries, there's a correlation between family SES and past achievements. You also can't do both of these at the same time. So this is one study. It's 200,000 students, but it's only for fourth graders. And so this may only apply to fourth graders. We'll have to see if this applies to high school students or college-level students. But the method is applicable in general. You can apply this and test students at very different levels. And the next step is to make it easier for principals and heads of departments to do this. So it's quite easy to build a computer tool to do simulations so students can, principals and teachers can move students around and see what happens. Thank you. Okay. Yes?
Renee Kassiljas from Stanford. I was wondering, are you estimating all those effects or those correlations at the same time? Or
Yes.
were they estimated one at a time?
They're all, this is one model. That's why it's so complicated. It's all done at the same time. They all control for each other.
And there were no issues of collinearity with all these variables that's slightly similar?
Well, this is, they're also, I didn't go into details, but we have indices. So we might have like 4 questions for, let's say, learning attitude. And then from that, we do a factor analysis to create an index. And that index will give us a better measure. It's more precise than each particular question by itself. And also takes care of that collinearity problem.
One last follow-up.
Mm-hmm.
So how do you see yourself going more towards a causal interpretation of these? I saw sometimes they're slipped in the effect, and at the end you're suggesting that teachers can change their makeup and infer how they might change their classrooms. What is the way we can read causal conclusions from this?
There's another step that I need to do, which is to create equal groups at the beginning. So there's matching algorithms. So propensity score matching, coarse and exact matching. So what we do is we take these different matching and Mahalanobis matching, distance matching. So we try these different methods, see which one gives us the best results in terms of 2 groups that are very similar to each other. And then we run it that way. So that creates a control experiment condition. So that's the next step to increase the validity here. Yes?
Wondering what model did you use that you could control for all these variables at the same time?
So this is a multi-level regression. And so it's basically regression, but it takes into account different levels. And so you're controlling for effects of different things all at the same time. And then so like, the answer to your last question is, that's not as good as having matched groups to begin with. So that's the next step to do. Yeah. Any other questions? Yes?
So for taking it to the next step and actually implementing something based on this, it seems like there would be a lot of potential parent pushback.
Mm-hmm.
Assigning students in particular configurations that I think parents who are not researchers and scientists would, even if they are, like putting their own kids in a situation where, what if their kid is the high reading, good attitude student with a class full of ones who aren't? That seems kind of like an inconceivable situation practically, where a lot of parents are not going to want to have their high ability student be the one that's the example of the rest of the class. I don't know if that's a practical implication.
Yeah.
This research, I'm not sure like that would fly in many classes in the United States. I'm not sure if that's possible to implement.
Yeah, so I think this is where the research is really important. So in terms of learning attitude, if your child has a high learning attitude, you're not really affected by students with low learning attitude. That's what the results show, that if low ability students are affected by people with better learning attitudes, but it doesn't go the other way. So if you have a good learning attitude, it doesn't seem to have an impact what the learning attitudes of people around you. It seems to be a one-way effect. So that's one part. So part of it's part of a general issue. We need to educate parents about what the real consequences are. So there is this folk idea that if your kids are smart, you're hurt by having students who aren't as smart. But actually, the results are the opposite. You actually benefit by having students who are not as smart in your class because you can explain things to them. And explaining is much more powerful than getting help. And so this is a very important piece of information that the problem we actually have is the opposite. Most parents believe that doing something will hurt their students, but actually it's the opposite of what they expect. So I think it's part of the education issue. There's also an issue of, I haven't talked about this, but if you have an actual tool where you can hand to a principal and they can like move students around and see what the impact is, there are going to be trade-offs. And so like, if you put a student in this class, they might learn more than if that student goes to a different class. But you can't optimize for just one student. You have to optimize across all your students. So there's conflict of interest there. That is not discussed. But I think getting to a point where even principals thinking about this would be helpful. Because right now, most assignments are just kind of random. Like a student's parent knows some teacher wants to be in that classroom, right? So there's already a social network effect. There's already benefit to richer parents more connected. So this will tend to work against that. So there's already a problem. This should make it less of a problem as opposed to making it worse. Yes?
Thank you for your presentation. I was quite taken by the breadth of the theoretical space you operated in, and that one initial slide showed the directional effects of each of these different factors. And then you specified the results and their significance. I guess my question is, do you see there ever being a better theoretical positions that are quantified, and so that the size of the effect you saw in your study was either used to support a riskier theory, or are we just going to be lucky if we get this directionally right?
I think this is where I'm really jealous of economists. Economists are already doing this. They have much better econometric models. They have much more precise measures. So they can tell you, if you have this policy, we expect it to cost like $300 billion, or 24 million people will not have healthcare insurance because of this, because they have these precise models. And this is basically moving in the same direction. So I think eventually education will be that level as well, where we have much more precise estimates of the impacts. Thank you.